So we're going to continue our discussion talking about slope. Okay, remember that worksheet you did? You still have it. Okay. You were given a bunch of coordinates like this, and you had to find the slope between a set of coordinates. Okay. What was the slope formula we used? Yeah.
y2 minus y1
Yep.
divided by x2 minus x1.
Right. So the slope, or m, equals the second y minus the first y divided by the second x minus the first x. So what you did was you went through and you labeled each set of points. You called one of them the first x, the first y, the other one the second x, and the second y. Then you plugged these coordinates in, and you got a slope, and you reduced that fraction, right? Remember, we talked about rise over run to. The top number tells us how much we go up or down. The bottom number tells us how much we go left or right. Okay. If it was a positive number, what would the line look like?
Left to right.
Left to right what? Yes. Uphill or downhill? Yeah. If it's a positive number, it goes left to right uphill, right? If it's negative, the slope, it's left to right downhill. Okay. Which type of line has a slope of 0? Horizontal or vertical? Right. This has a slope of 0. Remember, it takes 0 effort to walk across something flat, and it's impossible to walk up something vertical. That's what do we call that slope when it doesn't have an answer? Undefined, right? It's not. You can't define it. Okay. So that's what we did on that previous homework. Then the last 6, you had to find the missing coordinate. So you had time to do that last class. Hopefully everybody got that done. Okay. But you were using this slope formula to calculate this slope. Okay. Today we're going to focus a little more on graphs. We're going to talk about something called direct variation. So stuff that varies directly, okay, at a constant rate. So the graph of a direct variation always goes through the origin of a coordinate plane. What's the origin?
0, 0.
Yeah, 0, 0. This point right here. Every direct variation graph always goes through the origin. Okay, always goes through the point 0, 0. So today when you're graphing direct variation, you can always start at 0, 0. Okay? And every graph. And it varies directly, meaning in this case it looks like when x is 4, y is 1. When x is 8, y is 2. So when x would be 12, y would be 3. When x, it varies the same rate. Okay. In this case, this red line, okay, the x value is 4 times as much as the y value. So everywhere I go, the x value is 4 times as much as the y value. Okay. In this case, it looks like in the green line, the x value, I know it's kind of hard to see, but the x value is the exact same as the y value. If the x is 3, the y is 3. If the x is 4, the y is 4. See, they vary at the same rate. Okay. And then in the blue graph, it looks like the y value is 4 times as much as the x value. If x is 1, y is 4. If x is 2, y is 8. So if x was 3, y would be 12, because it varies 4 times as much. Okay, that's what a direct variation graph is. So the definition of that, when two variables are related in such a way that the ratio, remember ratio is a fraction, the ratio of their values always remains the same, the variables are said to be in direct variation. Okay? So if the ratio of their values is always the same, it's a direct variation. Okay? A straight line going through the origin. The direct variation equation is this. Y equals kx. Okay, this is what we call the direct variation equation. The letter k, okay, we call this the constant of variation. So part of the assignment today, I ask you, what's the constant of variation? You just look at what's the coefficient of x, or the number in front of the x. Okay? We say that y varies directly with x. For example, if the constant of variation was 2, if this k was 2, that means every y value is 2 times as much as every k value. Right? If k was 3, we'd take 2 times 3, y would be 6. If k was 5, we'd take 2 times 5, y would be 10. Or if x was 10, 2 times 10, y would be 20. Okay? And if the constant variation here was 2, every y would be doubled every x. Okay? This is the direct variation equation. Okay? So for example, this says write a direct variation equation. Y varies directly as x, so that's y equals kx. That's my constant. That's my direct variation equation. Okay. It says y is 8 and x is 12. I'm going to plug those into this formula. Okay. Y is 8, x is 12. Find k and write a direct variation equation. So I need to find k first. Well, this is just solving an equation. Okay, we've done this before. How do I get rid of this multiplication by 12 so that I can get k by itself? Well, yeah, what's the opposite of multiplying by 12? Dividing by 12. So I'm going to divide both sides by 12. That divides out to be 1. Divide that by 12. So 8 over 12 equals k. But I can reduce this fraction. What's the largest number both of these? What's the largest factor both of these numbers have in common? 4. If I divide the top by 4, that's 2. If I divide the bottom by 4, that's 3. So k equals 2/3. That's the first part of the problem. It said find k and then write a direct variation equation. When you write a direct variation equation, all you do is replace k. So I already know what k equals. So my direct variation equation, y equals 2/3 x. That's my two answers. So that means every y coordinate is 2/3 of every x coordinate. Okay? So if I take 2/3 times every x coordinate, that gives me the y coordinate. Okay? This is my constant of variation, or that's the k value. That's my direct variation equation. I started with y equals kx. I plugged in y and x. I found out what k is. And then I just wrote my equation based on having k. Does that make some sense? Any questions on this one? Let's look at another here. Y varies directly as x. That means I'm going to use a direct variation equation. Y equals kx. Y is 24 and x is 16. Find y when x is 12. All right, well, let's go back to this. I need to find k first. Well, y is 24, so I'm going to plug that in for y. And x is 16. Plug that in for x. Let's solve this equation for k. I need to get rid of this multiplication by 16, so I'll divide both sides by 16. So k equals 24 over 16. Let's go ahead and simplify this fraction. What's the largest factor both of these numbers have? 4 works. 8 would be the largest, right? So if I divide this number by 4, that gives me 6. If I divide this number by 4, that gives me, or sorry, by 8. If 24 divided by 8 is 3, and 16 divided by 8 is 2, right? So k in this problem is 2. K in this problem is 2, or 3 over 2. Sorry, 3 over 2. Okay. Now it says find y when x is 12. Well, if I go back to this direct variation equation, y equals kx, I now know what k is, right? K is 3 over 2. It says find y when x is 12. I'll plug that in for x. And now I can just simplify this equation for y. Solve for y. Yep, this is multiply, right? So remember, if you don't have a denominator, you can just write it over 1. You just multiply the numerators together. 3 times 12 is 36. 2 times 1 is 2. So I have 36 over 2, which is 18. So I found what the problem asked. Find y when x is 12. Which that makes sense, right? When x is 16, y was 24. So when x was a little less than 16, y had to be a little less than 24. Which makes sense, right? I didn't get something crazy big. They vary at the same rate. Okay. I used this direct variation equation. The first time I found out what k is, once I had k, I could plug in the x to find out what the y was. Any questions with that? It's using this is called the direct variation equation, y equals kx. All right, so now we're going to talk about the graphs here of direct variation equations. Remember, every direct variation equation always goes through the origin, always goes through 0, 0. Okay? Here's the equation for this line, and I'll write it bigger here, y equals 2x. This problem tells me to name the constant of variation for this equation and find the slope. Well, remember our direct variation is y equals kx, and which variable stands for the constant of variation? Y, K, or X? Right, K. So which variable is K in this problem? 2. All right, sorry, which number is 2? Right, 2. So K equals 2. The direct variation is 2. The slope of this line is also really easy to find because the slope and the direct variation are always the same thing. So the slope in this problem is also 2. Okay. Slope is the number, the coefficient of x, the number in front of x. This constant variation and the slope are always the same thing. Now remember, if it starts in the origin, okay, and the slope is 2, remember the top number tells me how much I need to go up or down, the bottom number tells me how much I need to go left or right. Well, there's no bottom number here on this slope. So what do I put for a denominator? Yeah, remember when there's no denominator, you can just write it, anything divided by 1, it's still itself, right? So you can just divide it by 1. So this says I rise 2, because it's a positive 2, and do I go to the right or to the left one? Right. I go to the right because it's a positive 1. So that means from the origin I would go up 2 over 1. There's a point. I could go up 2 over 1. There's another point. I could go up another 2 over 1. There'd be a point there. Okay? So that's what this equation is this line. Starting at the origin, there's the slope of up 2 over 1. Up 2 over 1. Okay? Now what if we had one problem like this on the last worksheet? Is this the same slope?
No.
What if you simplify this?
It's the same thing.
A negative divided by negative is a positive, right? Because this says you go down 2 and to the left 1. Is that the same thing? Down 2 to the left 1. Yep, there's a point. Down 2 to the left 1. Yep, down 2 to the left 1. Okay? So this is actually the same thing. Now this is the simplified version. Okay? But if you have a negative over a negative, that's a positive. Right? And then, since the slope is positive, the line is going uphill, which we expect, right? So in this problem, all we had to do was name the constant of variation, which is K, and the slope. And the constant of variation and slope happen to always be the same thing. All right, let's look at another here. In this equation, y equals negative 4x. What's the constant of variation? Negative 4. What's the slope? Also negative 4. It's always the same thing. Constant of variation and the slope are the same thing. And let's just make sure the graph is right. It starts at the origin. The numerator tells me how much to go up or down. The denominator, if there's not a denominator, I write it over 1, tells me how much to go left or right. So this says, since it's negative 4, I need to go down 4. 1, 2, 3, 4. And since it's positive 1, go to the right 1. 1, 2, 3, 4, to the right 1. Okay, that would give me this line. Now, let me ask another question. Is that the same as this?
Yes.
Is negative 4 divided by 1 the same answer as 4 divided by negative 1? Well, think if you simplified these. If you took negative 4 divided by 1, you would get negative 4.
Yeah, it's the same.
Right? If you took 4 divided by negative 1, you would get negative 4. So this is the same. You would go up, in this case, this slope says you go up 4, because it's a positive 4, and then to the left 1, because it's going to the left 1. Up 4 to the left 1. Okay? So if there's one negative, it doesn't matter if it's with the numerator or with the denominator. It just can't be with both, because then it would be positive. So again, that's just an extra question. The question itself asked what is the constant variation in the slope. The answer would be negative 4. Okay, we just wanted to make sure this graph was right. This one, the constant variation slope would obviously be positive 4, right? Because that's the number in front of the x. That says you go up 4 and over 1. Up 4 and over 1. That's the same thing as going down 4 to the left 1, because that's a negative over a negative. There's a negative 3x. We just did one like that. The slope is negative, so it's a downhill line. That says you go down 3 to the right 1. Again, negative 3 is both the slope and the constant of variation. They're the same thing. Yeah. So now let's graph one ourselves. Here's the equation, y equals x. Let me write it a little bigger here. Remember, the constant of variation in the slope is always the number that's in front of the x, or the coefficient of x. What is the coefficient of x here? Careful, if it was 0, it'd be 0 times x, which is 0.
1.
It's 1, right. So the constant of variation is 1, which is the same thing as the slope. Okay. At what point do all direct variation graphs go through? 0, 0. So I'm going to start right there at 0, 0. Okay? And then, all right, it's a big point. I'll reduce it a little bit. So, there's a point. Okay? Now the slope says 1. Remember, if it doesn't have a denominator, you can always just write it over 1. So this says it's positive. So the top number tells me how much go up or down. Up 1, then to the right 1. Up 1, to the right 1. Up 1, to the right 1. I'll plot a few points there. Once I have enough, remember I need to connect them with my line and draw my arrows on either end because it goes on forever. That's the graph of this direct variation equation. Okay? This is the graph. I started at the origin and then I followed the slope. Up 1, over 1, up 1, over 1. Okay. There are 6 of these on the assignment that you'll have enough time to probably get done today in class. Okay? 6 of these graphs. I'll give you graph paper and stuff. But you look at the direct variation equation, the number in front of the x, or the coefficient of x, tells you the slope. Alright, y equals 2x. Let's graph this one. Y equals 2x. So I'll start at the origin again. Okay. What's the slope of this line?
K is 2.
2. K is 2, so m is 2. The constant variation and slope are the same. So that means I need to go up 2 and to the right 1 because I can write it over 1. Up 2 to the right 1. Up 2 to the right 1. If I wanted to, I could also go down 2 and to the left 1 because that's a negative over negative. There's my points. Connect them with the line with arrows on both ends. And there's my line. Okay. That's the line of this direct variation equation. Any questions there? All right, let's do one with a fraction here. So, what's my slope in this problem?
Negative 3.
Right. I'll write it just bigger here. It's negative 3/2, or negative 3 over 2. So I start at 0, 0, because all direct variation equations go through 0, 0. Now, does this say down 3 and to the right 2? Or does it say up 3 and to the left 2?
Down 3.
Or does it matter? Does it matter? My question is this. Can you treat it like this or this? Let's see. If we went down 3 and to the right 2, that would be here. And if we went up 3 and to the left 2, that would be here. Looks like a straight line to me, right? Remember, if there's a negative, you can take it with either one, either the numerator or the denominator. You just can't take it with both because a negative divided by a negative is a positive. So, that gives me enough to draw a straight line. There's my line with the arrows. So if you have a negative out front, a fraction, you can take it with the numerator or the denominator, just not both. Negative 3 going down 3 and to the right 2 is the same as going up 3 and to the left 2. Okay? It still gives me this line. Again, the slope here is negative 3/2. The constant variation is negative 3/2. Question? Yeah.
Will there be both negatives?
If they're both negative, you could simplify it to a positive so that it would be uphill. Right, good question. So if you had something like this,
Like negative 3.
yeah, let's say you had this. Y equals negative 3 over negative 2x. So you could go through the origin, okay, and you could go down 3, 1, 2, 3, and to the left 2. But you could also simplify it. Negative divided by negative is a positive. So that's also the same thing as going up 3 and to the right 2. So there's that line. Good question. So if they're ever both negative, you can either treat them both negative or you can just simplify it to a positive and then do the slope. Okay. Good. Negative 2/3, again the same thing. I can either treat it as a negative 2 over 3 or as a positive 2 over negative 3. Let's say I treat it as a negative 2 over 3. That means I go down 2 and to the right 3. And then I could go down 2 to the right 3. Or I could have went up 2 as a positive 2 and to the left 3. There's my points. Connect them with the line with arrows on the end. All right, we're going to skip this activity today to do some of our assignment.